Okay, Assalamualaikum and good evening. Before we start, I would like to know, has there anyone been affected by the recent floods in KL or any other places, Pekan? Or do you know any of your friends who might have an issue with that? Or is everyone here in Dungun? UiTM Dungun? Terjejas tu because of rumah ke ataupun isu-isu yang indirect? Because I have to ni lah, so far perkeliling from UiTM officially is in regards to your assignment submission and whatever lah. Tapi since kita tak ada dapat any kind of assignment, I'm just wondering if today's class will have issues in regards to ni lah. So nak tahu juga ramai ke ataupun if it's just one or two person, I guess bolehlah continue dengan ni sebab we are at the end of our apa ni pun lecture pun, cuma itulah saya kena synckan dengan kelas pagi tadi, and regardless kalau kata dia tak boleh join this evening pun, there's a recording here so they can revisit this lecture anytime after the event lah. But itulah my concern is, tengok ni 14 orang, 13, 12 lah, baru 12. So I'm wondering if I think there's only one person that WhatsApp me just earlier this morning that has an issue. So I would assume we would have no issues lah dengan kelas. But just so you guys know, UiTM only apa baru keluar perkeliling just I guess just this morning kot, that assignment can be delayed. So I'm not sure whether it's applicable to you guys or not, but supposedly dia punya perkeliling tu mention those who are affected. So if you are most of you in UiTM already, so I mean of course tak ambil kira yang kena stay at home semua kan, but itulah, just to let you guys know, perkeliling have inform us as inform all lecturers to apa ni delay your apa ni lah submission. But again, I have to wait for the official punya notification from Rector pula. Biasalah dengar ni, ada autocratic sikit. So can't say for sure whether it's applicable to all students, but for now yang saya tahu is those yang affected are from Pekan and KL Selangor lah. Terengganu should not, I mean Terengganu I rasa adalah satu dua kawasan yang kena, but not as affected as Pahang and KL Selangor. Okay, so but regardless class, I guess for the class, for those who aren't able to join because of their issues with banjir tu, siapalah ada alasan, cuma kena notify, minta dia orang notify saya after the event ke, after dah settle down, so that I have some justification that in case lah somebody want to ask me, I know lah this student pergi mana. Okay, and I recorded this session again like every lectures so that they can revisit this for their test or even their mini project preparation. And for the next class, so today I'm going to finish up all the syllabus, and next class I'm going to brief you guys on your mini project. So I prefer to do it in the mass lecture so that it would be, because I'm the one who's going to mark both class. So I prefer to do it concurrently between the classes so that message to equal lah sampai, because I'm the one who's the marks will be at my end, not Sir Azri. So yeah, I have to make sure both class is at the same page. Okay, that's it. We are at 19. I guess we can proceed lah kot. Yang tak, siapa yang tak letak dalam kelas sebab banjir tu, okay lah. Nanti saya minta dia orang I either message me or let me know so that dia tak dikira spontane. Okay, so for the end, this is going to be the last of our syllabus. After that, you guys are going to be, I'm going to leave you guys alone for you to do your mini project. Except for the next class, because next class I need to brief you guys on example apa semua buat mini project semua tu. So, but in terms of lecture, this is going to be the last lecture lah, on measurement and verification. So we are actually quite early in the sense that supposedly based on study plan, we should be the end of chapter 4 by after Christmas. But even before Christmas, we have ended our lecture. So you get more power to you guys lah, for you to finish up your mini project. So take the chances, take the opportunity to make a proper report lah. And I will brief you guys on what the proper report looks like. So for the lecture today, we are going to look at measurement and verification. Basically, it's the same as, can I make it bigger? Hold on, yeah. Let me adjust my OBS so that the view is okay. Hold on, yeah. Okay, and then let me just present the video capture. Okay. Okay, so just in case somebody else want to join our class, I need to put this here. All right. So again, so today we are going more towards just a lecture. Today is going just to be lecture. Move to top. Why is it? Hold on, yeah. Okay. Okay, so measurement and verification again. It's actually I've touched this topic a little bit on the last slide, last 2 weeks, basically on what kind of option that you can do. So I'll just briefly revisit so that before we proceed with the next stage lah, which is more on statistics and how you can use your mathematical and equation yang kita dah buat last week, yang QSUM chart tu, macam mana nak guna equation EEI tu to calculate the savings. So again, briefly revisit what kind of option available for us to do measurement in order for us to verify our ECM that has been implemented. So there are actually 4, and even 4 we can divide it into 2, which is the whole facility and retrofit isolation method. For the whole facility, you have 2 options, either option C or D, where it basically means is that you guys are measuring the whole facility of the whatever organization that you're measuring, either your own or your client later on. The whole as you take the measurement as a whole, not just a specific EAC or specific machinery, meaning the whole administration building. And basically, if you're using it as a whole, you need to use the utility meter from TNB lah. Most probably you won't be able to install your own meter because due to the way wiring whatnot. But depends on the client. Actually, you can depending on how much the budget is. But the target being the whole facility lah. But and then for retrofit, for option A or option B, basically you isolate the either the EAC themselves or a bunch of other EACs together, as opposed to measuring it as a whole using the whole facility punya energy consumption lah. You just measure specific area or specific machine punya energy consumption, Therefore, you need to have a dedicated meter because you only measuring that machine or that area only. So you have to separate the energy consumption meter from the energy meter from the whole building, separate it so that you can get the actual EAC's readings lah. So that said, because it is dedicated, adjustment, any kind of what it meant by adjustment is the unpredictability, the variable that you might not know, like whether, for example, in a room, if the what you call that, if it's macam sekarang ni mendung je sebab hujan, so you might even siang pun, tengah hari pun you kena buka lampu kan, so energy consumption tinggi, so you have to consider adjustment to because of weather. Can be simple because you tap directly for that area only. So typically if you turn because if there's a people, chances are switch tu akan turn on turn off lah. So adjustment can be very simple lah because it's very localized. Whereby for the whole facility, adjustment can be complex because maybe certain area even though mendung tapi maybe the direction dia menghadap matahari ke and time to spot dia apa what you call that, tak semendung the other side punya building. So can be very complex lah sebab meter sama but building tu wing yang berbeza, so end up dia punya energy consumption pun lain, so does not reflect the actual ni. So it can be complex, of course you can solve it, but it may requires hefty capital to be invested if you want to know, if you want to crack down and properly address the adjustment that needs to be taken care of. Okay, so again, retrofit can be divided into two, option A and option B, and for the whole facility can be also divided into two, option C and option D. Option A may partially measure retrofit isolation. Basically, you are measuring some of the new installation, whereby option B, the whole new installation, but again separate from the whole facility. And option C, the whole facility. Option D, if you can't access the whole facility, you might need to simulate. It depends on whatever criteria that has been met. Okay, so first we look at option A, then we look at option B, then we look at option C and why, then we need to do option D. Okay, so A, partially measured retrofit. Basically, savings are determined by partial field measurement. That means even though it's the same EAC, chances are you only want to measure one machinery only. So you have to separate the measurement even though within an EAC themselves, but only to the ECM that has been applied, separate from the energy of the use of the rest of the facility. So engineering calculations can be done using short-term or continuous post-retrofit, meaning after you have installed it. Post, kalau pre, before you installed it. Macam post-grad, after you graduate your degree, then you can do your masters or PhD. That means master and PhD is post-graduation. I don't know why, but even master PhD pun sebenarnya ada graduation juga kan, but typically graduation tu people will stop at degree lah. So anything after that is considered as postgraduate lah. Okay. And then typical application why we are doing this is because saving of the ECM might be too small, so everything has been needs to be done very small scale. So any measurement, any kind of of course due to capital invested or available capital to be invested upon by the company. So if after doing some calculation or initial field study, it turns out that the saving realized only ni, so your manage only minuscule. So your management rather than invest tons of money, they decide no lah, just buat yang simple-simple je lah. So that's why you need to do partial measure retrofit. And interactive effects of the ECM on the energy use of other facility can be reasonably estimated or assumed. So if the effect of the energy being consumed in that particular machine eventually turns out to be almost minor, or maybe can be estimated, almost accurately, so might as well just use the estimation, not the whole actual value. And basically not insignificant. It is significant, but to the point that the capital to be invested isn't as good as the effect it has on the overall energy consumption. Maybe you guys just install a new standalone apa, kan aircon ada dua, satu yang centralized, satu yang unit satu sebiji itu je. Maybe tinggi tapi not as much as centralized punya aircon. So just to consider that one aircon takkanlah nak pasang meter sebiji kat aircon yang mahal kan, nak buat wiring lah apalah. So might as well just assume je lah ni based on data yang ada, calculate, okay ni energy consumption dia. So jimat duit. Okay, and then adjustment which affect the energy use are not excessively difficult and expensive to monitor. As again, the same as aircon tadi. Kita ada satu centralized aircon, the whole chiller unit semua. And then tiba-tiba satu bilik ni just nak one standalone aircon yang biasa kita pasang kat rumah tu. So tak susah pun sebenarnya for you to measure the adjustment. Ada orang on time panas buka, ada orang most probably akan terbuka aircon tu for 8 hours. So you can basically estimate it almost accurately. And if there are submeters already existed to isolate the use of energy, for me kalau dari submeter tu pakai je lah. So I don't really agree, but never mind. Long-term testing is not warranted because again macam aircon tadi, dia punya contribution towards the overall compared to chiller punya energy consumption typically would be in the fields of more than 100 kilowatt hours, whereby aircon kita assume, saya assume, I don't actually know the figures, around 30 kilowatt per hours. So it is there, it is not 100 lah, lebih sebenarnya. Kalau chiller tu I would assume almost 1000 kilowatt hours, especially if they operate 24/7. So almost 1,000, and then yang aircon is just 30 to 50 kilowatt hours per day. So there is some significance to the bill, but not to the extent that yelah 1000 compared to 30 tak adalah critical sangat kan. So long term testing tu is not as critical as chiller punya consumption, electrical consumption. So therefore you might want to use partial measure retrofit lah, because the cost effectiveness is not as significant. And then uncertainty created by estimation is acceptable. Uncertainty kalau aircon satu biji itu most probably because of orang on atau tak on je lah. So it can be not that complex. Macam ni lighting dia bagi contoh, lighting retrofit, power draw is measured, operating hours can be estimated, motor replacement, motor again turn on turn off je. There's no such thing as kalau temperature tinggi ke dia akan efficient, dia ada effect tapi not as significant lah. So maksudnya kalau let's say macam cuaca sejuk, suddenly that motor what do you call that, doesn't work as efficient, so consume more electricity. No, typically kat Malaysia, we are talking about Malaysia lah. Kalau you're talking about Antarctica, then yes, waktu Antarctica pula apa nama, yang 4 seasons punya country, they may have impact, especially if the temperature varies quite significantly, where the motor might be a bit sluggish during cold season, but more efficient during warmer season. So it can be significant in that area, but for Malaysia not so much lah. Motor replacement ni most probably you can just partially measure it, estimated it using your own calculation, electrical calculation lah. And then we look at another retrofit isolation. Basically this one is to do field measurement to which the ECM is applied, separate from, again, this is almost similar, but this time around maybe the whole EAC, not just specific area or specific machine. So all the key parameters measurements are measured. That means all, yes, it is EAC, the whole EAC, but all metering equipment must be there for you to do this. So basically it involves more capital to be invested upon, because you need to buy the submeter, and then you need to install everything at the correct point and make sure that the meter works correctly for the whole period that you're doing your ECM. It can be 10 to 20 years. So energy calculation can also the same. You can use short-term and continuous measurement of baseline and reporting period energy consumption, or you can use measurement of proxies of energy use. And the difference here is that the energy consumption can be a little bit bigger than the A version, because now the energy you're trying to measure can contribute to the whole facility punya energy quite significantly lah. Tadi maybe aircon sebiji, now you change the whole chiller. Now you want to measure the chiller punya efficiency and energy consumption. Now you want to pasang banyak lah meter apa semua. So the capital here when you're trying to do option B for your retrofit isolation is going to be huge as compared to A. Ni example dia bagi. One is a variable speed drive, another is new chiller. Interactive effect of the ECM towards the energy use of other facility equipment can be estimated the same as option A. Possible changes to the facility beyond the measurement boundary can be difficult to identify or assess because capital measurement invested here is very huge, and therefore some variable can be introduced by the whole system itself, which can go beyond what you might know unless you do some thorough punya investigation lah. Sebab very complex a bit. And adjustment which affect the energy use are not excessively difficult or expensive to monitor, although it can be, you need to do some proper investigation for you to understand what the adjustment. As compared to yang A ni memang direct. Kalau ada orang masuk office, most probably lampu terbuka. Kalau tak ada orang masuk office, most probably lampu tu a certain area je terbuka. The same go, but for B, it is slightly difficult, but not excessively difficult. Meaning you still can understand it, provided you do some investigation towards the topic. The adjustment that needs to be made. Okay, and then C. C basically the whole facility. You're measuring the whole facility. Tadi A is more on maybe just one aircon unit, maybe just one area of lighting. Whereby for B, the whole EAC, but not the whole facility, just the whole EAC, and most probably is going to introduce a lot of capital for you to implement option B. And option C, it may or may not cost that much, but you're subjecting the whole building, basically. Depends on your objective. And savings are determined by measuring energy use at the whole facility level. Therefore, you're using the whole TNB utility meters lah. Whole facility meters or submeters yang available to assess the energy performance of the whole facility. And how it can be calculated, basically you're measuring the whole facility utility meter data using technique from simple comparison to regression analysis. Can be directly January 21 to January 22, or you have to perform some sort of Y equals to MS plus C, the one that we have done QSIM chart sebelum ni. So some regression analysis might be ni lah, because there's variable yang kita tak tahu, so we need to predict it. And in order for us to, because we only have one meter, the whole facility punya meter, so chances are we don't know actually the actual variable existed yang boleh represented in the ni. So nak tak nak kena guna regression analysis lah for us to get prediction if let's say we don't have the data. Okay. And application here is that the energy performance will be assessed for the whole facility, not just the ECMs. And there are many types of ECM can be existed in the whole facility. So maybe because your boss doesn't agree to spend some money on you, so nak tak nak kena buat macam ni as a whole. So it might not be accurate, but at least there is some monitoring being done. And ECMs involve activities whose individual energy use is difficult to separately measure. So, for example, wall or window upgrade. Again, kalau window upgrade ni, there are tons of, yelah, macam mana you nak measure, apa nama, illumination of that area if you don't have the specific machinery kan. And then not only that, even if you have that specific machinery, certain area may not have the same illumination as the other area because of light reaching out to the inside of the building may be different from for each separate section. So maybe sebelum ni pakai windows tinted. Now you want to change to something that enables natural lighting. So you change the what you call that, the window to something that more light friendly, so natural light can come in, but at the same time not too apa, tak terlalu panas lah, sebab bila lampu masuk, apa, cahaya masuk, kalau open macam tu je most probably heat pun masuk lah juga kan, sebab apa, cahaya carry their own heat energy. So you might buy some window that allows that, and then but yelah, bila dah tak apalah, itu dah masuk sains fizik lah, saya tak nak cerita. Okay, and then so what it means here is that you can't measure the light that illuminated by the window, so you might as well lump sum it up for the whole building punya energy consumption lah, because measuring each specific energy consumption due to the ECM, due to the change of the window, too difficult for you, then measure semua lah. And then apparently if you change the window, that means you don't have to turn on the light, turn on the what you call that, the chiller that much, because now you have natural cooling. So savings are typically large enough for you to accommodate the cost punya, bukan maksudnya you implement cost tinggi. Yelah, of course bila itu tingkat building tu most probably mahal lah dia punya cost. But the saving itself large enough for you to underestimate the variable or adjustment that needs to be made. So reasonable correlation can be found between energy use and other independent variables. And energy use is measured in the electricity utility meters for typically 12 months or more. So you can't, if you're trying to measure 1 or 2 months, typically this won't be acceptable for Suruhanjaya Tenaga, because each month has their own difference kan. Maksudnya bulan 2, 28 hari dia kerja. So most probably your electrical energy of course akan kurang lah for February compared to June or July. So typically people will accept the report if it's more than 12 months for whole facility punya measurement and verification data. And then finally, option D, where you're only able to do a simulation because data isn't available or hard to get by, or it can easily be estimated. So what it meant by option D is that saving are determined through simulation of energy consumption for the whole facility, and energy use simulation calibrated with hourly or monthly utility billing data. That means after you have done your calculation, estimation, simulation, once you get the actual bill, then you readjusted your calculation to reflect the actual monthly bill. So some works to be done. I mean, the energy prediction might, because simulation kan senang je, maybe one day dah boleh calculate, tapi you have to downtime actual report to might be longer because you need to wait for the actual bill for the months to arrive for you to properly adjust your values so that it could reflect the actual energy consumption for that month. Okay. And then why we would want to do option D punya measurement and verification is because data unavailable or unreliable or can't hardly easy for you to get it directly. Energy use measurements after installation of gas and electric. Basically, this is the explanation. You can only get actual data from your simulation once you calibrated your data based on the electricity bill of that month. Baseline energy use is determined using calibrated simulation compared to simulation of reporting period. So once you got your simulated reporting period, then you need to readjust every single time for your calibrated simulation punya baseline lah. So to compare apple to apple. And then because baseline most probably that month is just February and this one is April. So that's why baseline needs to be bring to the same level as April because February has only 28 days where April have maybe 31st. I guess 31st and April. 31 days. 30 days. This year April 30 days. So I guess 30 days lah. So beza 2 hari tu quite significant especially if that 2 hari tu waktu bekerja is going to affect your electrical consumption quite significantly. Okay, so simulation software predicts metered calibration data with acceptable accuracy, typically more than 90% lah baru di considered as acceptable. And typical application where people would want to use calibrated simulation is for new building where previous data hasn't existed. Centrally metered campus or facilities, the same thing. And then software you could use is eQuest or Energy Plus, but I think I haven't had a chance to explore this because I'm not a practitioner. But I guess yeah, itulah Energy Plus and eQuest lah. Okay, and then why do we need to, okay, then we look at planning. Well, how to plan for measurement and verification. Of course, if you want to do something, especially when it involves the production of your organization or your client organization, you need to plan properly to reduce your footprint in the production area because nanti kan kacau lah production area punya KPI. Nak buat measurement and verification ni. So to reduce that, you have to plan your measurement and verification process properly. So why do we need to do planning of MNV? Basically, MNV plan is just a document that defines the procedures and methods to determine energy saving and energy efficiency project. So it's central of proper saving determination and basis of verification, and it allows to assure transparency of the MNV process so that everyone knows what you're trying to measure and the data verification too. Nobody can dispute that at the end of your audit process. Assure quality and credibility of MNV outcomes. Kenapa tak ada tempat lain ni? Sorry. So basically similar to macam menteri lah. Bila menteri datang, pumpang-pumpang, sekolah tu cantik, apa kemas apa semua. Tapi bila menteri tu tak datang, apa sepah-sepah kan. So the same thing lah here. So you need to plan it, not to say that you need to inform the boss of the section 2 months ahead. More like so that okay. More like so that everyone is aware that that month people going to come and measure. So it can be earlier that month, middle of that month, can be end of that month. But at least people are prepared so that some minor adjustment can be made to the production to accommodate the MNV process and not to interfere with the daily punya production so much lah. But at least still got some reflection of the actual data dynamics of the process that is being presented by the data. And then you need to plan so that all data needed for saving determination will be available and within acceptable budget. For example, macam tadi, kita plan because maybe that month, that particular day lah, for example, dia tak ada produce this product. So machine tu turn off. Time tu lah awak nak buat MNV for that machine. Memang tak boleh lah, memang lah energy tu ni sebab machine shutdown kan. So tak boleh lah. So if you want to plan, you must make sure that the schedule of MNV does coincide with the one that you want to measure, that it operates normally. Not because of shutdown ke, maybe that month tengah production tinggi ke, so data tu nanti tak reflect the actual normal punya ni lah. Okay, so when do you do MNV planning? Should be prepared during project feasibility, that means during initial stages lah, while ECMs are being designed. So jangan project dah install, dah pasang baru nak plan, nak buat MNV. No. Waktu project feasibility itself, waktu you tengah draw dia punya rangka kerja tu, is when you should also plan when to do the MNV. Preparation should commence as soon as the ACMs, their intended impact and estimated savings are known sufficiently to define the MNV requirement. So how to do it? Okay, there are first steps here. You have to list the kind of ECM objects, the constraint of the ECM, so that you know how to properly measure it, so that all the data is available and does reflect the process, and not some other yelah nak measure ECM1 for example. Tiba-tiba because tak plan, main terjah aja. Now you're measuring ECM3. Padahal you tak prepare pun for your ECM3. So kena tahu awal-awal lah. And then waktu you measure ECM3 tu pun dah ni tak tahu. Yang maybe at that time sebenarnya constraint dia apa nama? Machine tu is not operating at 50%. It's not operating at full potential. Most probably at that time maybe sebab production rendah. Now it's operating at 50% only. So of course data energy consumption dia rendah, which tak reflect lah. So have to know lah, prepared before, and then know what the ECM does, and know what limits the ECM has, and then you evaluate whether it is A, B, C, or D punya option that you need to follow for you to conduct the MNV. And then evaluate any kind of risk or cost of each of these options. If you want to do B, berapa banyak submitter kena install, or A, the same thing. And then whether it's actually feasible or practical for you to realize that cost versus the amount of data that you might have from that. If it's acceptable, proceed. If the cost is also acceptable, because you might want to install tons of submitters in option B. If it's acceptable by the client, then yes. Then you start MNV plan, and then that's it. Okay, so the objective that you need to know when you realize an MNV plan is that it must be done continuously, it must be done annually, and the energy determined from the whole building must use utility meter lah. So jangan mengada-ngada nak install another meter, interfere with TNB punya ni if you're trying to do option C or D. Okay, and some constraint that you might want to know whether you want to pursue either of these options is the availability of historical data from available utility, whether there are or no dedicated utility meters, whether there is interaction between each ECM that has been installed, and whether or not the ECMs involve a small portion of the whole baseline energy, whether or not the ECM does belong to how much percentage the ECM does contribute to the whole baseline energy of that building or the whole organization. Okay, evaluate and select MNV option, which is the second stage, is this one is too much of a wording, but basically the one that I've mentioned, you need just to select whether A, B, C, or D, depending on whether the constraints or the budget or the objective that you want to realize does reflect the objective, the end result that you might want. Or whether to use a single ECM or multiple ECM depending again on the objective. So yang lain tu baca lah sebab panjang sangat ni. Basically that's the same things that I've just discussed. However, okay, what is the risk involved in saving risk and cost ni? Basically, whether independent variables such as weather, production, and occupancy can contribute much towards the end result of your data. Any kind of static factor that may result in your data being not viable, not actually correct, Any degradation of the ECM, maybe this is the fifth year after you install the ECM and you're trying to do measurement and verification. So there might be some efficiency apa ni lah, downgrade lah at the year of reporting tu. The operating hours, maybe you're trying to measure the machinery. You need to collect the data for 4 hours, for example, and then you're only able to come into the area at 3 o'clock, where people would log off their work at 6. So you only have 2 hours data only. So that's the risk that you might want to know. And estimated ECM performance and operation, so that you know beforehand what you could expect the data, so that you don't have to go back and then observe your data. Oh, rupa-rupanya patutnya kalau normal maybe 2.5 volt. And bila balik tengok-tengok data semua 5 volt above. So rather than ni, you might want to check balik dekat plant tu betul ke operation salah ke, ataupun maybe connection data. Yeah, ni typical especially when you're mining dengan data. The actual data that you expect 2.5, tiba-tiba balik baru dapat 5, dan esok kena pergi balik kat site. So itu pentingnya kena kenal sistem tu. That means waktu you dapat je data 2.5 tu, ni something wrong ni. 5 tu maknanya ni something wrong. You can do the adjustment directly before you start collecting the 4 hours data tadi tu. So tak payah ulang alik and then spend another day for 4 hours dekat site tu. Tak nak lah kan. So now you have to know the data, how the data would look like, so that you don't have to go back and recollect until another time pula. And then what are the costs can be contributed towards MNV for evaluating the step 3 ni is basically project cost, which is the materials and labor involved in the MNV plan, any kind of markup, if let's say there's a design, project management, insurance or tax, any verifier fee that you want to engage in terms of verifying that the data is correct. And if the selected option does not meet the required saving risk, you need to choose another MNV option, and can be iteratively be refined to satisfy the MNV requirement of project ECM budget. Meaning, if let's say you dah buat option C, data tak betul, you can revisit back, do it again for option A, for example, rather than option B, because option B mahal sangat. And now option A most probably be able to ni. So that means realize your objective. So that means now you're able to reflect the data more accurately. So what it meant here is that this MNV plan you can iteratively done as long as you're able to achieve the objective. So macam tadi lah, data dah salah collect, terpaksa lah patah balik ke site. Either that or you choose the option C pula now for the whole facility after you found out that per data collected even if salah, does not reflect that much, so might as well just use data C, lagi senang, ambil dia terus daripada bill. Okay, and finally prepare MNV plan if only can be done after you have met all the risks and the saving and the cost, then only the MNV plan can be developed. So this is the contents. Basically ni chapter 1, chapter 2 macam itulah at each of the report. So semua ni boleh tengok sendiri, but basically your proper MNV plan reporting should have objective, options, the previous data, the current reporting period punya data, any kind of adjustment being made, what procedure, analysis procedure that you have done to make sure that you can bring the baseline to the same level as the reporting period punya data. The current energy prices, what meter has been installed at the area to get the data. Monitoring responsibilities, who should the report be, the process of the report being validated, the data has been once calculated, also analysis, who approved the report and before the report finally being received by the proper energy committee lah. And then what kind of accuracy that is expected, because of course you can't be 100%. There's no such thing in life as 100% sure. we only know what we know. So if that person say that they 100% know this is correct, either that person is a fool or that person does not know much. And then budget, what kind of budget involved in the MNV plan, and the format of the report, who should be reported to, basically the processes lah, the report should follow. Q&A, any kind of quality assurance procedure to make sure that the MNV plan does provide a quality data. That means the data is undisputable and whatnot. And other information that you might want to push for the next MNV plan. Maybe try to, instead of now option C, now you might want to do option A, or maybe you want to do option D, depending on the data availability. Okay, and then we look at the, what do you call that? Adjustment, measurement, and uncertainty. Okay, this one involves tons of statistics, as you can see here. This is statistics, and then we look at the actual application. So why do we need to consider uncertainty? Because in any kind of data measurement, any kind of data processing, there's errors in it. So error can occur in the modeling if you're choosing option D example. And data error could also existed in metering because the person who's measuring the data might not took down the data correctly, or maybe the cable might have degraded over time, so the data does not reflect the actual data being consumed. So there's error there. And also sampling, when the data that you have collected, what do you call that, does not follow the proper sample time. That means only a portion. That means you're measuring only after 12, whereby the machine started at 8 a.m., for example. So the data during normal processes does not actually reflect during the startup of the process. So that means the energy loss has not been captured in your data. So sampling you tak betul lah. So error can occur most probably in these three areas. You might want to look at it lah. In order for you to make sure that your report is correct, you need to express your uncertainty properly, and therefore you need to address these two questions. How big is the error margin? How yakin you are with the data? So therefore we use statistical precision statement. One is the plus and 20% accuracy of the data, and the other one is how yakin you are with that margin tadi tu. So typically people will say saving that you have gotten from your MNV plan estimated at 1,000 kilowatt hours with 20% chances that the number, even though lari pun, will fall between 95%. How much? Let's say between 500 kilowatt hours to 900 kilowatt hours. And you can guarantee that at 90% confidence level. That means you jamin this number will fall between 20% of 1,000 kilowatt hours plus minus at 90%. That means you tak yakin 100%, of course, force of nature, force majeure, apa nama, unpredictable confidence level, unpredictable weather and whatnot. So there are big chances that data you have collected for that month falls between 90%. You can guarantee it falls between 20% of 1,000 kilowatt hours plus minus. So this is the statement that you need to include when you put your report. When you finally done with your report, you decided that the saving is at this, and then you must include this statement so that your report can be considered correct, or that yang proper punya energy committees for those energy manager wouldn't question you lah. Okay, so this is an example of MNV plan where you need to show this is the summary, only the summary, where you mention what are the project is this ECM involved, what are the outcome expected, what are the MNV option that you have implemented, and so on and so forth. So this is an example of the plan that you need to submit to the energy committee beforehand, before you do. Not the actual report, but more like apa nama? Before you do the work. Pre MNV plan, basically MNV plan planning kan, sebab dia tengah at the starting stage before the work is being done. So you need to submit this before you do the work, before you start to do the work. Okay, then let's say you have done the work and you got the data. So, and apparently this is the data that you have compiled for the period of between June 2010 to May 2011, 1 year. So you collected each month punya number of working days. Of course, each month ni ada dia punya working days, cuti raya lah apalah. And then cooling degree day depending on the weather for that month, and the actual consumption that you have calculated based on for this year punya energy data lah. Okay, so this is the example of data. So first, you can do single variable analysis, which is number of working days versus consumption. So you want to study the effect. This is actually the one that we have done for QSM chart. Basically, you're doing the EEI punya trend line ni to get the regression analysis estimation with R squared, with Y, so that you can use it to predict or adjust the baseline towards the reporting period. Again, baseline is this one, 2010 to 2011. Reporting period can be June 2011 to May 2012. The next year punya iteration. So maybe next year tu iklim tak betul ke, banjir macam sekarang ni. Tahun lepas tak banjir, tahun ni banjir. December. Tahun lepas December tak banjir kilang you. So you have to bring that tak banjir tu kepada level yang banjir, because yang level yang nak banjir ni yang you nak report ni kepada your client. So you need to adjust that. So that means you need this equation y equals to untuk bawa ke tahun ni, so that yang baseline ni reflect tahun yang reporting period. Ini is the baseline punya equation. So that means for the next year, for June 2012 to May 20 June 2011 to May 2012, you need to do the reporting period punya EEI, and then once you get the equation, you bring these values to the next year punya equation, so that you can bring the trend line to sama level, apple to apple, with the next year punya energy consumption. But basically this is single variable analysis for the baseline using the QSM chart yang proses yang saya dah discuss last week. So you'll be able to get this data. And let's say, okay, now you're measuring June 20, ni tadi May 2011. Now you're measuring June 2011 to May 2012, the next year punya reporting period. Okay, this one is the post retrofit data. That means the reporting period punya data. Ni be careful. This one is the one that you're going to put into your mini project nanti. So you have to know this. So this is the next year, the actual year that you're trying to make a report is. And then once you got this, the equation for this, sorry, this one is factors 16658x, just the consumption. Hold on, let me confirm post retrofit. So 840 is 849. Oh, this one terbalik. This one yang post retrofit data ni yang dibawa ke baseline, so that maybe time, okay, ni depending on the actual apa ni lah. Maybe time baseline itu lah actual normal. Tiba-tiba yang this year punya measurement that you're trying to use because of MCO, data tu nampak macam banyak kurang, so tak proper lah. So this one dia bawa yang tahun 2011, the next yang tahun ni punya data ke tahun lepas. So they use equation EEI tahun lepas baseline ni, they carry this value X dengan apa Y punya, sorry bukan X dengan Y, apa MX plus C ni dia bawa yang ke tahun depan, so that now it reflects apple to apple with the last years. So you can get the adjusted consumption for post retrofit. Ni adjusted baseline data. Let me confirm jap. Yalah betul lah. 825 ni dibawa ke baseline and then no. I think this one is okay. Sorry, I patah balik. I think what I've said just wrong. Yang this one is actually okay betul. This is the actual data for the year that you want to measure. But sorry, saya terfikir benda lain agaknya. Basically, this data 849543 ni dia bawa ke equation ni so that they get the baseline punya adjusted data so that it can be calculated using this one. Sekejap, hold on, 840 sampai 849. Okay, I'm a bit sorry, saya semalam saya dah ni dah. Let me confirm that 840 430 energy avoided. Okay, let me confirm. Give me 5 minutes. Ataupun take a 5 minutes break because I need to confirm this since kita pun dah sejam. And I'll continue at 8, I guess 8:35 or 8:40. Let me confirm this before nanti kan saya bagi wrong info pula kan kacau lah awak punya project. Hold on ya. Okay, kita continue because lagi cepat ni badan nak habis dah pun. Sikit lagi. Okay, so basically what I said tadi tu is actually in a way betul tapi not so accurate lah because we did bring the baseline, sorry, not the baseline, actually the pre-reporting period punya data tu towards the baseline punya level. That's why we put the equation ni lah. We use the equation from the baseline to calculate the adjusted. The reason why saya confused tadi sebab saya nampak ni adjusted baseline data, and I assume when I know that this is actually we bring my understanding was my baseline tu yang bawa ke sini, but actually no, yang this year reporting period is actually being brought back to the baseline because we are using the number of the reporting periods punya days back to the baseline punya level, which is we use the equation from baseline punya data tu, so that it does reflect the year reporting period punya actual data. So again, takkanlah every single year kita nak bawa baseline tu berubah kan. Instead, the year yang kita, actually we can do this patah balik sebenarnya because this is just estimation, and also if you want to do it pun boleh sebenarnya, it's up to you to get your data to reflect, to get your data more accurate lah in terms of energy saving. So that said, what it's being done now is that since you have calculated and get the actual estimation for the baseline data, so for the reporting period punya data, after you have retrofit the ACM, you bring the number of working days ni to the baseline punya level. So that means 23, you multiply with 16658x ni, and then you plus the crossing, the Y crossing ni, 457,296 ni, then you get the adjusted reporting period punya data. So instead of 825,301, the adjusted data should now bring the reporting period punya data, the one that you're trying to measure, back to the baseline level so that you can compare it apple to apple. And then once you got the result of the equation, because now you bring 23 multiply with 16658 plus 457,296, you'll get 840,430 for June 2011. So in order for you to check how much, sorry, not how much lah, how much lah energy saving that you actually got is by how much, what I'm trying to construct proper words. How much is actually data being saved, but in the sense that you're referring it to the baseline punya equation, baseline punya level. So I'm not sure the correct word is, but the actual energy save is between 840,430, you minus it with 825,301. So although this is actually the recorded value, but you adjusted it according to the baseline to get the energy saving. Sepatutnya kalau ikutkan baseline lah, 849 tolak dengan 840, but it's not like that because you need to make some adjustment because again, this is just estimation. You don't have the actual data and you can't do proper adjustment, so you might have to do analysis lah. Ni basically the, what you call that, the error due to modeling lah. Metering, sampling, you can actually get it properly, but modeling error because adjustment needs to be considered due to different level of working days for this year compared to previous year. Like for example, in July, 24 days, but for July 2011, 23 days only. So to cater for that error due to number of working days ni, you need to use the linear equation that you calculated for the baseline, and therefore you need to bring the data that you got for this year back to the baseline level, and then you tolak, so that yang sebab memang dia punya equation is baseline tolak, if you remember, savings is baseline minus the retrofit data kan. So this is actually baseline because you bring the number of level working days to the same level of the baseline. So now this become baseline. So now this minus this, you get 15,129. Bukan this one bukan 849 ni. Sebab 849 ni is actually June 2010 punya level. Now because June 2011 punya level lain, which is 23, so you bring it using the estimation pemala lah basically, due to effect of variable adjustment. So now the actual baseline you need to calculate is based on the equation. So 840 tolak 430 tolak 825, then you get the actual energy saving for that month, after your retrofit the data. Okay, hope faham lah apa saya cerita ni. Because you can't exactly use 849 443 ni. Memang equation is baseline tolak actual data, reporting data. So ikutkan, kalau ikut logik 849 minus 443, tolak je lah dengan 825 301 kan, sebab 23 days, 23 days. But you have to remember, the profile of the energy tu sebenarnya, because this is using statistical, you need to compare it with the whole 12 month punya data, so that your data is actually correct due to difference in temperature lah, difference in occupancy rate, difference in whatever adjustment that you may not know. So for you to actually do that, you need to bring yang profile baseline ni kepada the next year, the one that you're trying to measure, and then bring the number ni so that it can reflect baseline yang previous year tu to this year, then you can compare it apple to apple. I hope my explanation is ni, tapi again, no matter how much I try to explain it, it depends on you juga. So I suggest before you do your mini project, try to revisit and then try to focus on your data, your sets of data, then compare it to actually faham apa yang saya cakap ni. Okay, basically we can't use this because this year punya profile might be different due to other factors that you might not know. So you have to use the estimation dynamic ni for the year ni, you bring it to next year so that it can actually reflect the baseline punya energy consumption properly for the year that you're trying to measure, and then you'll be able to use the equation saving minus baseline. Saving equals minus baseline minus reporting period punya energy consumption. Okay, I hope my explanation is clear. But again, boleh revisit balik. So in terms of easier to understand, okay, this is baseline. Now because we multiply it with the month punya working days, now you bring the baseline to the same, orang kata average tu the same level lah. Maknanya kalau sebelum ni baseline start dengan, if we can, saya tak boleh conteng, boleh ke? Ya, boleh rupanya. Sorry. So okay, maybe baseline start at 1 for example. Now because the reason why we do this is because we want to bring it, okay, let's say kita tukar ni jadi warna biru. Okay, this is the reporting period. Reporting period start at 2 for example. So in order for us to compare these two, you need to bring this instead of 1. Now you bring it to the same level at 2. Warna merah. So now baseline ni macam ni, for example. Now. So now it start at 2 juga. So that's the reason why we do this. That's the reason why we calculate the EEI, got the equation, and then bring this 23, 22 ni, working days yang tahun ni to the same level for us to betul-betul tolak. Now it start at 2. Before this, they start at 1. Maybe sebab tahun tu tak ada monsoon ke, tiba-tiba tahun ni monsoon berat ke. So now we bring it to the same level. Now we can compare apple to apple. Now baru betul. So that means bila awak ada data nanti for your mini project, don't simply use the previous year tu and then you tolak terus dengan tahun ni punya data. It's not correct. Especially I think mostly pun memang guna cara macam ni lah. You have to do the ecosystem chart ni, get the y equals to something ni, then you bring the value, the variable that you want to calculate, and then get the adjusted baseline. Now you can minus, because previously it started at 1, now you bring it to the same level as the reporting period, which is at 2 or 0 depending. Then now you can tolak betul-betul lah average dia tu. Okay, next kita tengok single variable analysis lagi sekali, but now we are looking at cooling degree days. Cooling degree days ni meaning instead of, biasalah bila sejuk macam sekarang ni, your aircon will not be working all kalau macam 8 jam tu 8 jam straight dia on, tak, compared to time panas. Sebab you have to remember aircon dia basically especially if you try to use the mode yang efficient tu untuk jimat api, time sejuk they may not operate 100%, 95% pun. Most probably just 70% because cuaca dah sejuk, so dia tak perlu banyak power dia perlukan for it to produce the level of cooling that you want compared to during cuaca tak sejuk, time panas. So dia kena sentiasa on dia punya cooling element itu. So that is what we call as cooling degree days, because at certain level your aircon may not consume that much electric, whereby waktu panas your aircon might be working overtime lah to make you feel comfortable. So CDD ni it can be in terms of what's the unit? I'm not sure, but there's no unit I guess here. I'm also not very familiar because I'm not an air condition guy. I'm just a lecturer and mostly main dengan robots. So cooling degree days ni I think would be degree Celsius per kilowatt hours I guess. So the numbers kita ambil it, kita take it at face value. That means the numbers ni assume lah ini is the value yang betul untuk reflect 2010 to 2011 punya energy consumption. So as you can see, data for baseline tadi kita pakai apa nama? Working days. Now we look at CDD to determine consumption of electricity depending on CDD punya variable. So the same thing, first kita buat QSUM for the baseline data. Then for the next year, we bring the CDD to the same level, the baseline to the same level of reporting period punya level. So macam baseline tadi, start dengan for example 1. Now at the year that you are trying to measure, 2011, now data maybe start at 3. Tengok nombor pun 500 kan. So kita assume je lah. So maybe data dia macam ni. So to bring this to the same level, we need to multiply it with the equation so that now the baseline also start at 3. So let's see gambar dia macam ni. For example, now we can compare it directly, apple to apple. So in order for us to do that, we bring the CDD value, multiply it with the sensitivity, and then the cross section, which is the base load. Now you get the actual data of baseline, and then you 824,593 ni minus 825, then you get your actual energy saving. So in this case, minus 708, that means actually it uses more energy lah for previous year. Sorry, energy avoided minus 708. It uses more energy, adjusted consumption. So actually baseline minus ni, yalah. So that means because during post retrofit ni, your energy after you have installed ECM apparently uses more energy than after you have before you implement the ECM, even after you have adjusted it. So it shows that you're actually using more energy, maybe because this is at the first stage kot, waktu tu dia belum sampai dia punya operating parameters efficiency. But after that, as you can see, the energy saving is almost consistent at more than 10,000 kilowatt hours. So the same thing lah with the one that working days tadi, cuma this time around you're using CDD. Of course, it has to have its own equation for you to bring the baseline data to the same level as 2011 and 2012 punya data. Okay, so the same thing before that, before we bring it down, we start at different, macam ni nampak ni, the first point ni. The first point started at different, which is I'm not sure berapa ni, but in order for us to actually refer to the same area, we have to bring this to the new level, which is now it start at the same starting point lah. Macam tadi, negatif 3 tadi tu, daripada 1, dia pergi ke 3, so that we can tolak directly. I think yang ni pun sama, nampak? Ni starting pun sama. So, because it's important starting ni. Kalau paksi dia berbeza, that means tak boleh tolak directly. You have to bring it to the same level, then only the data, the calculation will be correct. Reflect the actual dynamic of the process. Okay, then let's say you want to see whether working days or CDD that actually affect the energy consumption. Sorry, mana data tadi? This one. Is it number of working days or is it CDD that actually kacau consumption ni? So in order for you to know that, you have to do some statistics punya ni lah, which is multiple R squared. So R squared ni, if you recall kat sini, slide sebelum ni, which is this one. So R squared shows how close the correlation between the energy use and the independent variable. So between tonnage and consumption. So, and for this example, how accurate lah basically, number of working days and the consumption, or between cooling degrees and energy consumption. So if you got something more than 70 or 80, typically it needs to be more than 0.75. So that means this one needs to be more than 0.75. This one also needs to be more than 0.75. Sorry, for it to be considered as betul lah, number of working days memang effect consumptions. Betul tak? Cooling degree days affect consumption. So R squared ni yang bagi tahu how accurate that is compared to the other variable, compared to the energy consumption, sorry. So it needs to be 0.75. So in this case, I'm not sure which one this is, but regression statistics, this should be CDD or number of working days, but I guess this is the two of them together. And then because when you do, if you open SPSS, if you do the SPSS, I'm not sure whether you guys business, I think you guys pun ada pakai SPSS. You can actually compile together two variables to see the result of statistic analysis too, as compared to the output. And I guess this is a combination of both. And yang ANOVA intercept ni, I wouldn't say this is my field. I'm only using it back then for my PhD tu pun sikit je. So I'm only using p-value and also Pearson lah. And significance ni, I'm not sure whether I did. I think I did significant F ni, but basically it needs to be, p-value needs to be less than 0.05 to show that the regression does capture the dynamic of the energy consumption though. So as you can see here, need to be less than 0.05, then yes, significance does show that the variable analysis between CDD and working days does result in actual, the equation tadi tu betul, tepat, so betul lah, boleh terima. But however, between number of working days and CDD, apparently CDD is the more, that has more direct influence over energy consumption as compared to number of working days, as shown here, because number of working days indicated that the value that it got for T-stat is more lesser than 2. So it's not that significant. P-value means that it needs to be 0.05 for it to be considered as impactful to the output, which is the energy consumption. So it shows here it's 0.104. That means it's bigger than 0.05. That means that's why these two numbers shows that number of working days is not as significant as CDD, because CDD shows all the right parameters. 2.2 is more than 2, 0.04 which is lesser than 0.05. So CDD in this data, what you can what it indicates is that number of working days, yes, it has an impact based on R squared, based on significant F. It does have an impact towards energy consumption, but compared to two, CDD is more impactful compared to number of working days. It has some significance, but not that much. CDD, it has significant impact, and it does provide an impactful result towards the output, which is energy consumption. So this is analysis that you could do. Of course, you have to refer to lecturer statistics lah to better understand what is standard error, T-stat, lower, upper semua ni. I'm electrical engineer, so this is out of my field, although I dabble a bit when I did my PhD. So take it with a grain of salt, whatever that I've just said. But I think even if you show this recording to your statistics lecturer, I think he or she would agree. If I'm wrong, then I would have to say that because I'm a lecturer, electrical engineering, bukan statistics. But since I dabble a bit, I think I am able to elaborate some of it. Okay, and then at the end of it, you can combine those two variables at the same time to calculate because now we know that CDD is actually the one that has major impact. So you can use also the same, you can still calculate, but the actual impact will be more on CDD, of course. And to better reflect it, even though working days has less significant impact to the output, it still has an impact. So you can use the two to calculate the actual energy being consumed for the baseline, then calculate the energy saving considering these two variables. So 8,189, I'm not sure 8,189 ni mana datang. Oh, this one, coefficient ni. Dia guna coefficient of the statistical analysis, and then standard error ni is dia punya intercept, I guess. No. Is the intercept the same 468, 483, and this one 457296, which is different than this one 435689. Dia guna mana? Oh, ni intercept ni. 435, 689. So basically, after you've done your regression analysis, if you have two variables or more, then you have to do your SPSS. You have to know your SPSS lah, for you to be able to come up with the actual equation here, for you to calculate and adjust the baseline to the same level for these both variable in the same level, so that you can actually get the energy use for the year, to compare it with the year that you're trying to measure. So this equation is actually penting if you have two variables. So my suggestion for your mini project, try to get only one variable lah. Jangan guna dua. But if not, if you still use two, of course you can get high marks, but it's going to be a bit more complicated because now you need to prove your equation based on SPSS or statistic, and any kind of statistic software that you might want to use for you to be able to come up with the actual correct adjusted baseline. So my advice, either use one, or if nak go memang markah tinggi for mini project, guna SPSS lah, which is compare two variables for your input. Okay, and then in order for you to be certified as, because measurement and verification can give you actually tons of money, especially for those energy manager yang company they appoint themselves, and then they might not have that specification or training yet, or maybe they don't want to burden, I mean, they don't have the technical knowledge, you can actually become a certified professional in manager in measurement and verification. People will hire you just to do measurement and verification after you've completed this training, which is CPMV by Green Tech. And I'm not sure because I haven't had the chance to join this, and I would assume this is 3 days. 3 days punya event. So this is in 2016. I'm not sure whether they are still doing this, but I would think so, given that current government pun dah start kena kutuk hari-hari dekat UN. So I think this will still be applicable in this year, if you're interested. But of course, look, dia punya fee dia 2,500 per pax. So it's not cheap, but it will enables you to do freelance work. So that means if you're working as an energy manager, it is quite worthwhile for you to invest in this training, so that rather than you focus on your company je, now you can do freelance work for other companies as well. Again, I think your generations punya dynamic in terms of buat duit is more seronok, because zaman saya pun dah start dah, of course, but before me, my seniors I guess, the only way nak cari duit is either meniaga or kerja, but you have to make it as full time. But zaman awak, given that there's online presence and also this the complexity of our nature today punya business nature, there's tons of passive income that you could generate with technical know-how lah. Even nak buat YouTube pun, you have to, even nak jadi YouTube influencer pun, you have to be able to know how to technically gifted lah dalam making videos, presentation and whatnot kan. So jangan pandang rendah sangat lah technical stuff ni. Susah sebenarnya, especially waktu nak startup tu, which is in this case 2,500 kan, quite susah juga. Okay, anyhow, that's for today. Thank you for your time. Do any of you have any questions in regard to today's punya content, especially bab-bab ni, calculation ni, because this is going to be the gist of your mini project punya apa ni, isi lah yang I would look at. Ada questions? Okay, if there's none, for next class, I'll be elaborating more on your mini project and just that. So I will take only maybe half an hour or 1 hour of the class time, but still important, especially for those yang apa nama, kalau ada isu macam hari ni ke, that day is ni lah, hopefully by then korang dah boleh join lah. In terms of our briefing of mini project, because that's going to be, not to say ni, depending on apa ni, if I can recall, it's 30% of your carry mark, I guess, if I'm not mistaken. Correct me if I'm wrong, but significant jugalah towards your carry mark. So I need to make sure that you do your mini project properly juga. Okay, so I guess that's all for today. Thank you for your time. Have a great day. Hopefully everyone stays safe, not only because of banjir, but also COVID. And hopefully you guys can, if you are affected by the banjir and flooding, I hope you guys can recover quickly lah, especially damages to your PNP punya devices and whatnot. Okay, thank you. That's all. Assalamualaikum.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome.